All right, so I'm streaming right now. I'm going to send the URL to the whole class, so people who are outside but they want to get started, they can get started too. And I'm on YouTube Studio. Mhm. Almost there. Okay, finally. Okay, so we are ready to go. All right. All right, so I'm going to explain this lab a little bit because you are going to need some extra explanation in this case to get it started. And for whatever strange reason, the projector is not showing my entire screen, even though I thought I fixed it. So let me fix that one more time. Nope, it's at the right resolution. So I just have to do the auto setup. Nope. That is very curious. Auto setup. Okay, switch back. Well, it doesn't want to do the auto setup, so you're only looking at a little portion of the screen that I have. Okay, but that's okay. All right, so to do this homework assignment, you will need to know how to use code blocks or some C programming environment. Okay, if you have taken the class in C or C++ programming and you know how to use a command line compiler, that's fine. Okay, there's nothing wrong with that. But on the other hand, if you say, I only know how to do it in Visual Studio, and you don't have Visual Studio installed on your own computer or on the computer that you want to use to do the homework assignment, you can use code blocks. So I'm going to show you how to get to code blocks. Okay, code blocks. And if you search for that, the first link is the correct one. How many people know how to use code blocks? All right. So for those of you who know how to use code blocks, there are still specific steps that you have to follow for this homework assignment. So you might want to still pay some attention. So code blocks is an IDE. If you download the correct version, it will include the debugger and everything that you need for the homework assignment. So when you go to downloads, okay, there are several versions or several options for Windows. So let's go to download the binary release. And under Windows, you see there are all of these options here. So what you want to do is to figure out which option you want to use. And personally, I would either use, so you want to use the one that has MingW or WINGW as a part of the description. You can use the setup.exe or you can use the zip file. I believe the exe is an installation program. So you need to have administrative right on the computer in order to install the program as a usual regular Windows program. The zip file, on the other hand, unzips into a nested structure of subfolders, and you can do it on the thumb drive. And then you can run code blocks from a thumb drive without having to install it on the computer, which makes it very handy. Okay, you just carry that thumb drive with you, plug it into the computer that you want to use, navigate to the folder, and you can start code blocks that way. Okay, so it's up to you. Whatever you do, whichever one you choose, make sure that the one that you download and use has MINGW in the name of the executable or the zip file. Is that okay? All right. So it's free. You don't have to pay for this. You can uninstall it, when you're done with your homework assignments. So, do we have any questions about how we can get code blocks? All right. So if there are no questions about code blocks, then we'll go ahead and start with the actual homework assignment. Okay. So let me go find the correct. There we go. All right. So the homework assignment. Let me zoom in a little bit. There we go. So the homework assignment starts with, a link at the beginning. It says to copy this file to your own Google Drive. This allows you to edit the cells, blah, blah, blah. So this link will give you a spreadsheet. It will link you to a spreadsheet. Okay. When you enter your student, you make a copy first. Okay. You make a copy to your own Google Drive. Then you input your student ID. It will give you your specific test case for this homework assignment. So your test case is dependent on your student ID. Is that okay? So that's the first step, is your test case. The second link, which is over here, is an archive of the code blocks project they can start with. In other words, I'm providing you a partially done program. You just have to finish a subroutine instead of writing the program from the beginning. Is that okay? So I'm going to pretend that you're over here, and you just say save link as. Okay, it is supposed to be just a zip file. Nope. Okay, I have to click on it. Okay, so it's a zip file. If you click on it, you should see the same thing, and then you click download. And the name of the file that you're downloading should be 11.zip. Okay, if you see something else, that means you might have done one of the steps incorrectly. Okay, so go ahead and download this file. Okay, in Windows, if you want to open it, that's fine. In Linux, you can just download it to a folder, and then we can unzip it later. So let me just do it one more time. Okay, I click on the link incorrectly, so let me just do it one more time. This time I click Save File, and I'll put it into my temp folder. Okay, because I don't need to keep it around for too long. Okay, so now we have the zip file downloaded. So the next thing you need to do once you have the zip file, in Windows it's easy because you can just double click on the zip file and unfold the zip file onto a folder. And I once again recommend putting the zip file or the unzipped version of the file into the same thumb drive where you have code blocks. So this way you have one thumb drive and you can take it to any computer, plug in, and get your homework done. Okay. So I'm going to unzip it using the command line because I'm using Linux. So there we go. So it should create a subfolder of the same name, which is 11. Okay. So in that file or in that folder, there's a file with an extension of CBP. That's your code blocks project file. So when you open the CBP file. Do not open just the regular C file because that is not going to work very well. Is that instruction okay? All right. So I'm going to show you how to do this because I do have code blocks installed on this computer as well. So it works almost exactly the same as what you would see, but it's a little bit different. Okay. So there we go, and I just click OK. There we go. All right, so this is my code blocks. Your code blocks should work pretty much the same way. So go to Open, go to the folder where the file is located. It's 11 in my temp folder. And remember, open the CBP file. Okay, opening the .c file is not going to be very helpful. So you open the CBP file, click Open, and there we have it. Okay, so we have most of the stuff here already. When you go to the project pane or projects pane, you can click on the expansion arrow on sources. These are your source files. Okay, one file is main.c. You do not need to modify main.c. Okay, if you want to see how the program works, you can go ahead and read the main subroutine, but you don't need to modify it. Okay, the other one is parse.c. So parse.c contains the parser that will parse the syntax that we talked about on Tuesday. Remember the regular expression stuff? I got the code to parse it, and it will give you the correct structure to begin with. So it will give you a quote-unquote mantissa that is a unsigned integer. It will give you an exponent of 10 that is a signed integer. So you start with those things already. Are we good so far? All right. So the other things you have to do is to go to project, and you have to set programs argument. Okay, so do not forget to do this step. So when you get here, go to program arguments, and then specify -n, and then whatever number that you are supposed to work with. Okay, so that part depends on your student ID and what the spreadsheet is telling you that your test case is. So I'm going to assume 1.23E45 is the number that I'm supposed to work with. Now, obviously, this is doesn't have a negative exponent, so to make it more realistic, it is E -45. So do not forget to do this step, because if you forget to do this step, the program, the main program is not going to know what number or what value you're supposed to convert. Are we still doing okay so far? All right. Question? You go to project, and then you go, okay, let me show you again. So you go to project, and then you go to set programs arguments. And then go to the middle part of the screen, which says your program arguments, and then you type in -n, and then the string or the number that you're supposed to work with. All right, are we good so far? Okay, you good? All right, so now we click OK. Now, depending on which code blocks you're using, I think some of the computer or some of the installations of code blocks in this lab has a problem. So, I will show you how to find the debugger later on. But assuming the installation is correct, okay, you need to go to exp10 to 2, exponent of 10 to exponent of 2. So go there, and you will see a shell of a subroutine. So when you see the shell of a subroutine, put a breakpoint over here, right at the close curly brace, like so. So to set up a breakpoint in code blocks, you just have to click next to the line, between the line number and the actual line content. Then it will set up a breakpoint. To remove a breakpoint, kind of click on the breakpoint itself. It's a toggle. So one click puts the breakpoint there. The next click will remove the breakpoint. Okay. So now when my program is ready to run or ready to be debugged. To debug a program, do not click the green arrow, because that will run the program in production mode, which does not get it into debug mode. Use the red arrow instead. Okay, so click on the red arrow to debug a program. So when you click that, if everything is installed correctly, it will compile the program and it will start running it. Okay, and you will see this message, the perspective, blah, 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 has changed. Do you want to save it? You can click yes or no. It doesn't really matter. Okay, so I click yes. So you can see that the program has now stopped or paused its execution, because on top of the little, it's not really a red dot. It is actually a stop sign if you look very closely, but from a distance it looks like a red dot. But on top of the stop sign, now we have a yellow triangle on it. The yellow triangle reflects this is where the program has paused its execution. So the program is still active, but it's not running. In other words, the variables and of the pointers and everything can be examined at this point. Are we still okay so far? So it might be a good idea to listen to me instead of trying to follow the procedure, because if you're following the procedure, you cannot hear what I'm saying. And then if you're one step behind, then everything kind of falls apart. So it's good to kind of just listen to me for the time being. So once you're here, you see that the subroutine has a single parameter, which is a pointer to a structure. Okay, so you want to know what is in the structure. Okay, in other words, at this point, I want to know what I'm given with this program. So you can do a few things. Okay, you can go here, and I think you can right-click on the parameter, and then go to watch PN. Okay, that will give you what we call a watch expression, and that will show you what the pointer is. Okay, but I don't think it will show you what the pointer is pointing to. In other words, it doesn't show you the structure, the members of the structure. So my personal preference is to go to the command prompt and say print. Okay, so print PN doesn't do anything. It just gives you the pointer. Where is it? Setting breakpoints. There we go. Okay, so I just have to scroll down a little bit. Okay. So you can see, well, you cannot see, but when you do the same thing, you will see that it will just give you the address of the structure, which is not very helpful when you're debugging your program. So what you want to do is to print *pn, or show me what is the structure that the pointer is pointing to. So when you do that, okay, I don't know why the scrolling, why it needs to be scrolled. So when you do this, it will show you that the structure the pn is pointing to has a few members. It has sign as a member. So for any value that is non-negative, sign is going to be a 0. For any value that is negative, sign is going to be non-zero. Are we good so far? So this is consistent with what we talked about on Tuesday. The next one is the Mantissa. Okay, the Mantissa is 123 in this case, because remember, I don't want to use double when I'm trying to convert something into double. The next one is exp10, or the exponent of 10. But it is not negative 45. It is negative 47 in this case, because I need to decrease the exponent of 10 by 2 in order to compensate for shifting the decimal point so that we go from 1.25 to 125. So are we still doing okay so far with this? Because everything that I'm talking about right now is consistent with what we talked about on Tuesday. Okay? And then the last one is the exponent of 2, which is currently 0. So this is the beginning, this is the start state of the structure the pn is pointed to, and that is what you are going to use as your starting point. Are we still doing okay so far with how to get to the starting point of the code that you have to write? Okay, we got some nods. Okay, I don't see anyone shaking the head. Okay, all right. So assuming this is all okay, the next question is, what do I want you to do given that this is your starting point? So the actual assignment is, or the description of what I want you to do is in the assignment description itself. So let me go find the quiz right now. There we go. All right. So your code should take the structure pointed to by the parameter pn and preserve the value v. So what v is really just the Mantissa times 2 to the power of exp2 times 10 to the power of exp10. So v should not change throughout the execution of your code. Okay, I need v to be preserved as much as possible. But I need exp10 to be 0 when your algorithm is done, because that's the whole point. Okay, I don't want any exponent of 10 after the conversion. I only want to have exponent of 2, and it can be any integer in this case. So as you might guess, because the number is really small to begin with, so your exp2 should probably be a negative number, and it should be a bit more negative compared to exp10, or the original value of exp10. Is that part okay? Yes? Okay. So the next one says the represented value v should be preserved as much as possible. So that means I look at I look at the Mantissa, I look at the exp10, which should be 0, I look at exp2. So if I apply all of those to compute v, I should see a very minimal, if any, change of v when the program is done. All right? So are we still doing okay with what your program is supposed to do? Okay, but there's a little bit more restriction here. So let's see. Okay, I'm just going to continue to read here. In the following editing area, when you open the quiz, you will see an editor area. So when you're done, I just need you to report back what is the Mantissa when you're all done, and what is your exp2 when you're all done. exp10 should be 0, so I don't need you to tell me what exp10 is, because that should be 0. To run the program with your specific test input, do the following. Okay, this is the same instruction that I have already told you, verbally. And that's about it. So that's the only question. It's worth your 4 points. You don't have to turn in your code. You just have to turn in the structure, okay, or the content of your structure. So one quick and easy way to do this is to go to the debug window in CodeBlocks, okay? And then you have this, print pn. It's hard for you to see, but this is the output from the debug window. So just Control-C, and then switch back to the browser. Go to the answer window over here, Control-V, and you can turn that in. Now, obviously, if I turn this in, I'll get 0 points because guess what? It does not meet the requirement of what I'm looking for. I think there's one additional requirement, which is kind of hidden somewhere in here. Oh, there we go, the first one. Forgot to talk about this first one. So the first one says the Mantissa should end up as a value that has bit 63 set. So the Mantissa is a 64-bit unsigned integer. So what that means is when you're all done with this, okay, in your answer, this Mantissa here should have a lot of digits. Because if you have a 64-bit number and bit 63 is a 1 and it is interpreted unsigned, how many digits are we talking about in base 10? Remember I told you guys how to do a really quick conversion? Every 10 bits is about 3 digits in base 10. You remember that? Sort of, okay? So we have 64 bits. In 64, how many 10s do we have? There are 6, right? So we know in base 10, there are at least 18 digits, right? But wait, there's more. Because we got the extra 4 bits. 2 to the power of 4 is 16, okay? So potentially, you can have 19 to 20 digits for the part that I'm highlighting here. So instead of 3 single digits here, you should have a lot of digits, okay? It should be 19 to 20 digits, depending on your actual Mantissa. Is that okay? All right? So you probably want to double check to make sure that your Mantissa meet that requirement, that bit 63 is a 1. All right? So now you need to get started with your actual program. So where do you get started with your program? You have to go back to the notes. So let's see, we go back to the notes, and then we go to floating point number representation. And in here, we jump to conversion from base 10 scientific notation to double. And it has 2 subsections. So the 2 subsections has to do with so everything that we want to do is inside section 5.2, but within section 5.2 it has 2 cases. The first case is the exponent of 10 is less than 0 to begin with, and then the second one, you probably guessed, is the exponent of 10 is more than 0. So which one should we focus on, 5.2.1 or 5.2.2? What is the name of the lab again? Negative exponent, right? So I'm guessing 5.2.1 is where we need to get started with. So this stuff here, we talked about it on Tuesday already. It's just that it's presented here, in a slightly different way. But this is where we get started. Do we have any questions at this point? Okay, so let me give you a little bit more clue, okay, just so that you guys have a better starting point, because usually people have some questions about this. Okay, so I'm going to go back to the quiz right here, and I look at these values, and I ask, what am I going to do with this, right? Now, don't give me this as an answer. I'm only using this, as a, okay, let me take this out into a notepad so that people don't accidentally think that you can do it over here. There we go. Okay. Obviously, exp10 is not 0. So set up a loop. Okay, you need to set up a loop. As long as exp10 is negative, stay in that loop. Okay? Is that okay? So you need an overall loop to basically say, if exp10 is negative, if it's less than 0, we want to perform another iteration of that outer loop. Okay? So one iteration of the outer loop should increment exp10 by 1. Okay? In other words, the goal that we have is to end up with something like this after the first iteration. Then you go like, well, the only way that we can increase the exponent of 10 so it gets closer to 0 is we have to do something to the Mantissa. What do we have to do to the Mantissa? We have to, no, because we're increasing exp10, which is the same thing as multiplying v by 10. So in order for v to stay the same, what do we need to do to the Mantissa? Divided by 10, because I made an adjustment to exp10, so I have to divide the Mantissa by 10. I look at this Mantissa. If I divide 123 by 10, I get 12.3. I'm going to lose the 0.3. Okay? 0.3 in 12.3 is a lot of percentage. Okay? That's like 2% something. I don't want to have that kind of error margin. So remember what I talked about on Tuesday? How do we minimize the error when I just want to divide something by 10? No, not quite. Okay, so the first thing we need to do is to make the Mantissa as big as possible. Do you guys remember that? Oh, yeah. More or less? Okay. So let me fix. Okay, so I'm going to get rid of this. So I'm going to copy and paste this again. So the first thing we need to do is to make the Mantissa big. So we have 246. But in order to do this, I have to change the exponent of 2. Because if I double the Mantissa, I have to decrement the exponent of 2 so that v maintains the same value. Does that make sense? Okay? So I look at this and go like, well, it is 246. Is that the largest value we can represent using 64 bits? Remember, the largest value that you can represent in 64 bits has 19 digits, 19 to 20 digits, right? That's not even close. So we say, well, let's do this again. Now, I'm only doing this by hand to show you, what logic you might want to employ when you work on this program, okay? So now it is 492, and then exp2 is -2, and we have to keep going. So how many times do you think we have to keep going like this before we get to we get Mantissa to a point where, oh, if we double again, it's gonna roll over? How many times? Okay. Not 18. It's a little bit more than 18. Okay, so you have to think about 123 first. Okay, how many bits do I need to represent 123? What is the closest power of 2 that is less than or equal to 123? That's 64, right? How many bits do I need to represent 64 as a well, okay, the question already implies it's a binary number. So how many bits do I need to represent 64 as a binary number? 7 bits. Very good. Okay, because it's 1 followed by 6 zeros, because it's 2 to the power of 6. Okay? So we have 1 followed by 6 zeros just to represent 123. I want that 1 that is representing 64 to go all the way to bit 63 in a 64-bit number. In other words, what used to be bit 6 needs to be bit 63. So how many times do I need to double the Mantissa to get there? 63 minus 6. So, Okay, so we have to double Mantissa. Now this double is not the type. This double means double the value. Double the Mantissa. In this case, 63 minus what did I say? 6 times. So that will give us 57. You do not. Your while loop. Your while loop needs to know when you have to stop, but not by counting. So you have to look at the Mantissa and say, can I double again and not overflow what a unsigned value can represent? So what do you think that logic is going to look like? Let me say that one more time. Okay, I think the notes actually talk about that. So let's go back to the notes. Nope, not that one, right? That's close. Okay, that's what we want to do. Okay, so what is the condition to stay in the loop to keep doubling? Okay.
Our number is greater than our number times 2.
Okay, the times 2 is problematic, okay? Because what we want, okay, this is what we want to express. We want to say if the Mantissa times 2 is greater than or equal to the max value we can represent using 64 bits, okay? So max, Okay, by the way, there is a constant you can use from the library so that you don't have to type in the, kind of problematic the 20-digit number that represents the largest value in a 64-bit number. Okay, so I will show you that a little bit later. So if you say, this, that's a problem, right? Because max is already the largest value you can represent using 64 bits, right? Can anything be greater than that value? No. So what do? We divide both sides by 2, okay? Yeah. So when the Mantissa is greater than or equal to the largest value that you can represent as an unsigned 64-bit number, it's time to stop. Because if you double again, it's going to exceed what you can represent in 64 bits. Does that make sense? Okay. So now the question is, how do I figure out this max? There's a painful way, and then there's an easy way. The painful way is to go through that calculation using your calculator and figure out what is 2 to the power of 64 minus 1, which is going to be a 20-digit base 10 number, and then type that into your program. It works, but it's not the best way to do it. So the best way to do it is to look into, I wonder what is in standardint.h, which is one of the header files. So of course, it's going to complain because it's thinking .h is a domain name. So we'll have to say header file stdint.h. So you look it up. Okay, you go to Wikipedia or one of the other pages. I don't care where you go. Okay, you go here, and then you look up the definitions. Okay, I'm going to zoom in a little bit here. It's pretty long. Okay, so it would go through the type defs of the various types, and if you look into the type def of the structure, it uses uint64_t as the type of the Mantissa. Okay, so you keep reading. Okay, keep going. Keep going. And somewhere there's a limit. Okay, there we go. Limits of specified with integer types. Okay, and then you keep going. Now these are the equations that I have already talked about. So that should not come as a surprise because we did talk about these ranges when we talk about signed representation versus unsigned representation. And then it talks about limits of minimum width integer types, and limits of fastest minimum width, limits of integer types capable of holding object pointers, greatest width, and let's see. I think I might have passed the one that I want to look at right here, staring us in the face. Maximum value of exact width unsigned integer types. Okay, so you look at this, and someone's going to type in exactly what it says right here, uint n underscore max, and that is not going to work because n is italic for a reason. What do you think? Why do you think n is italicized? Because that's the number of bits. And what is the number of bits again that we are dealing with? 64. So if you use uint 64 underscore max, that will give you the constant that defines the largest integer value you can represent as a 64-bit unsigned integer. So that is the least painful way to get to that number. Are we good so far? Yep. All right. So getting back to Notepad, there we go. So that is the constant, okay, which you're going to put over here, and you have to divide it by 2. If the Mantissa is greater than or equal to this number, this quantity, you better not double it again, because if you double again, you run out of bits to represent the product. Are we good? Okay. So once you get out of the loop, your Mantissa should now have, bit 63 being a 1, it should be a pretty large value, right? So now you have the Mantissa being a gigantic value. Okay, I'll use an example here. Okay, so don't think this is the actual case. Okay, so let's say the Mantissa is this gigantic value. It's the last number you can represent using 64 bits. Okay, by doubling the Mantissa over and over and over and over again. Okay, and at this point, exp10 is still negative 47. And exp2 is really quite negative because we have doubled it how many times again?
A lot.
57 times, to be exact. Okay. Is that okay? So you look at this and go like, but Tack, we haven't done a single thing about the exp10. What are we going to do here? I think we are ready to divide the Mantissa by 10. Okay. I think the amount of precision loss is going to be a little bit small. Okay, right now. So you go like, oh, okay, so Mantissa equals to Mantissa divided by 10, and exp10, gets incremented, right? Okay, but there's a problem here, okay? When you do an integer division, what happens? There's an implicit truncation. Okay, I'm gonna close the door. Okay, so it's gonna lose precision. So what do we do to do the rounding? Plus 5 before the division by 10, okay? So I'm not going to write it down because I don't want to give you the actual code, okay? You guys have to do some work. Okay, so once you do this and adjust the exp10, then your exp10 is finally one step closer to 0. Then what do? You go back and check. Is my exp10 0? No, it is less than 0. Then what do? Go through this whole thing again. Make the Mantissa as big as possible again. Add 5, divide the whole thing by 10. Add 1 to exp10, go back and check again. Okay? So without actually typing the code, I have just revealed the actual logic of what you need to implement. So are we okay with this approach? Okay. There's one more thing, just one more. It has to do with this thing here. Because remember, we have to add 5 to it before we divide it by 10. So this value can the Mantissa can potentially, be exactly at max divided by 2. So that means, oh no, excuse me, it can be exactly max, okay, at this point, and we don't want that to happen. So that means we have to remember to do a -5 here first, because we want to make sure that when we double Mantissa, we still have room to add 5 before the division by 10. So don't forget this little subtraction of 5 on in the comparison, because you want to make sure that you have the room to add 5 to Mantissa before you divide it by 10. Because if you don't check for that, there are very few cases where it can happen that Mantissa plus 5 is going to exceed what you can represent in an unsigned representation. Then your answer is going to be way off. Okay? So you don't want that to happen. So when you compare, just be careful when you're comparing. All right? So I think that kind of describes what you need to do to implement this program. And once again, it is really all in the notes. Okay? So if you read the notes on section 5.2.1, it describes the logic to get this program to work. So this is one of those things where you probably don't want to count on using the lab time alone to get this to work. So you're going to have some work to do over the weekend, possibly sometime next week. It's due next Thursday, so you do have 1 week to work on it. Okay, but don't expect that you can finish this during lab time. Some of you may be able to do it, but I wouldn't expect you to be able to do it. Any questions about this lab? I know I just spent a lot of time to describe it, but I think it's necessary. If I just open the lab and let you guys figure all this out, I think it would take you significantly longer. So are we good? All right. So, yeah, go ahead.
Can you look at something quick and tell me what I need to do to get this working? I downloaded the one you talked about
Mm-hmm.
from a flash drive, opened it, and it said you specify debugger program and debugger settings,
Mm-hmm.
debug, and
Okay, so that is exactly what I was talking earlier. When you use the PC version, some people, for whatever strange reason, it doesn't have the debugger pointed to the right place. It's actually there already. It's just not at the right place. Okay, so let me come over. The recording is still on because I want this part to be recorded, at least the audio. So let me take a quick look here. So I'm continuing to stream so that people who are listening at this point can kind of tell what to do. So if you use the lab computers, the debugger is installed, but it doesn't know where to find it.
Mm-hmm.
So the way to fix this problem is to go to Settings, and then go to Debugger, and then you go to GDB/CDB debugger, and go to Default. So when you get to the default in the debugger settings dialog box, the executable path is going to be red. Now, I know you're looking at this, but I'm talking to the stream.
Totally understand.
So you click on the ...
Okay.
to look into the folders. And then what you need to do is to point it to the right place. The right place is under this PC, under the C drive, under Program Files x86, under CoBlocks, under MinGW, under GDB32, under bin. Then you find gdb32.exe, and then you double click or click open, and that is how you specify the path to the debugger.
Got it.
It's a little bit painful, okay? And then you click OK, and then you can reset the debugger. So you can basically start, continue, run to cursor. We can start again. Build fail. Okay.
Oh, I should comment that stuff out.
It is still not running. Build fail. Okay, so let's check. Oh, EXP10 undeclared. So your program did not compile. So I'm just going to comment out all of this stuff first, because I just want to verify that the debugger is working. There's actually a faster way to do the commenting out. Okay, so I've commented out most of the code, and we'll put a breakpoint here, and run it again. Did you specify your number?
Yes.
Okay, so let's check.
It might have. Oh,
Nope.
it
Okay.
changed when I put in the.
Possibly. Okay, so don't forget to set your program arguments. Click OK, and then we run it again. Now we get it.
Got it.
Yeah. Oh,
Okay.
so that instruction works. So just to
And
go
now
back
you
to
do
the
rest of
stream.
stuff.
Yeah.
Got
So
it.
just to go back to the stream, you go to Settings, go to Debugger, go to Default, go to Executable Path, and the path reads as C:\/ program files in parentheses x86 code blocks mingw and then /gdb32 /bin and then /gdb32.exe.
Cool. Thank
All
you.
right, you're welcome.
For some reason, it just exited my program after I.
Okay, hold on. Let me turn off the recorder because I think your question is specific to your program. So I'm going to turn off the recorder, turn off the stream.